One of the least understood aspects of indexes is that if you include a function on a column in your where clause, then Oracle won't be able to use any standard indexes on that column. Note this applies to using a function on the column in the where clause, not the value itself. When you include a function on a column, what Oracle has to do is to read each row out of the table, compute the value from the function, and then perform a comparison to the value provided. Because what you're asking Oracle to do is to find all of the rows that match the computed value from the function, not the actual value stored in the table and in the index. Too often, someone is trying to fix a functional problem, like needing to perform a case-insensitive search or searching for some string that's embedded into another field with a substring function. Consequently, they become focused on the functional aspects of the problem and forget about the performance aspects. But when you use a function in this way, Oracle won't be able to use any of the regular indexes on the table. As was discussed in the Advanced Indexing Techniques module, one solution to this problem is to create a function-based index over the computed value. If you're doing something like a case-insensitive search or phonetic search, this should be your first option. Function-based indexes work very well, and they're a proven solution to these problems. Just make sure that the function you use in your where clause matches the function used in your create index statement exactly. Otherwise, Oracle won't be able to match up your statement with the function-based index. The other types of functions I frequently see used in where clauses are functions to do some sort of data cleanup or data conversion. These are functions like trim, toDate to convert a date stored as text into a date data type, or substring to extract out part of our string for comparison. In each of these cases, you could use a function-based index and this would work. But you may want to ask yourself a deeper question in each of these cases, and that is the data modeled correctly? If you have leading and trailing white spaces, why is that not being cleaned up at the front end when the data is inserted? If a date is stored as a varchar data type, why is this? Why isn't that date being stored as a date data type? And if you're constantly using substring to extract a value out of a larger field, maybe that field should be split into two fields. In each of these cases, there very well could be a performance problem, but this performance problem is most likely just a symptom of a larger data modeling problem, and that is probably causing pain in other areas of your application as well.